This time we are going to talk about OR gate. And like always, I'm going to start from the distinctive shape symbol. Now, please take a look how I draw it, because many students have difficulties to draw the OR gate. So you're supposed to draw the curve and another curve and start from the bottom. Another curve. Okay, this is shape of the OR gate. And we have input A and input B, and this is my output X. OR gate can have two or more inputs. You can also draw the OR gate using the rectangular outline symbol, which looks like this. And I have input A and input B. This is my OR gate 2. Now, what we're supposed to do next? We're supposed to draw the truth table in order to understand how it works. TT stands for the truth table. I have two inputs. I have A, B. We said that anytime we have two inputs, we can apply 4 combinations to this gate. So I have 0, 0, 0, 1, 1, 0, 1, 1. Keep in mind this is binary 0, this is binary 1, this is binary 2, this is binary 3. And this is my output. Output is going to look like this: 0, 1, 1, 1. So anytime we have 1 at the input, output is going to be 1. Now, many students have difficulties to remember the truth tables. Let me show you my way, how I learn how to remember the truth table of the OR gate. OR gate. OR. OR is the choice, okay? We prefer always to get something than nothing. So, I have 0 or 0. What you prefer to have? Basically, you have no choice. So you choose 0. We have 0 or 1. We prefer to have something than nothing. So that's why we have 1. 1 or 0. We prefer to have 1. 1 or 1, we have no choice. So that's why we have 1. This is one of many ways to remember the truth table of the OR gate. Now, if it comes to the gate with more inputs, the concept is exactly the same. If you have OR gate with 3 inputs, for example, A, B, C, and you have output X, you are going to have low at the output only when all inputs are going to have lows. But if at least one of them is going to be high, output automatically become high, okay, according to this table. And this concept is going to apply to all OR gates, no matter how many inputs they will have. If all inputs are 0, output is 0. If at least one of them is high, output automatically become high. Okay, so this is the truth table of the OR gate. If it comes to the logic expression, okay, so we have again OR gate, and we have inputs A, B, and this is my output, and we are going to write OR gate in this way: A, positive sign, B. This is A or B. Okay, so this is the expression, logic expression for the OR gate. For example, if you have expression which looks like this, for example, we have B or C. So without thinking too long, you're supposed to automatically know that this is OR gate, which has two inputs, B and C, and output X. If you are going to have, let's say, expression A or B or C, this is nothing else, just the 3-input OR gate. And if I'm going to have, let's say, expression A or B or C or D, this is 4-input OR gate. A, B, C, D. Okay, this is my output X. Okay, so now we can start do problems.